All right, have you ever done this? It's Friday night, 2 a.m. You are staring at a stack trace. You need some inspiration, so you go trolling through an old hard drive, looking at your old projects, because you want to relive the glory days of past victories and stuff that you've made, and like, oh yes, this was good. So you start scrolling through your old code, you open up the IDE, and you kind of get this realization that, so you open up an old project, and you get this realization that like, oh no, this was not the good vibes that I was looking for. This is the opposite of this. This is not what I wanted. You close the project, and then you delete the project. And then you burn the hard drive. Because you forgot how bad you were back then. How could anyone be this bad? So that happened to me recently, and so I decided I thought I would share what I found from my journey back into the past and try to salvage some kind of useful information from that. So, what you're about to see is real. Names have not been changed to protect the guilty. Consider this your NSFW warning. If anyone wants to leave, now's your chance. Okay, the story begins in 2004. This was a game called Red Moon. I was 13. It was a wildly ambitious third-person jet combat game. That's a jet. In case you can't tell, those are aliens. I don't know. So this was a third-person jet combat game. It was written in Java. I recorded with an unregistered copy of HyperCam 2. And it was a Java software renderer that I pretty much copied out of a book that I got from the library. And the parts that weren't copied verbatim out of the book were horrendous. But the part I want to talk about that was interesting that I found when I was scrolling through this code was the weapons, which are these little things right here. Those are guns, apparently. I created this thing by actually graphing it out on graph paper and typing in the coordinates in the text file, so it was pretty bad. It was bad. Anyway, I wanted multiple weapons that you could switch between. I was all about, I was 13, I was all about like awesome weapons. So, weapon switching, here it is. This is some of the animation code. I don't want you to look at it too hard or think about it too hard because it's real bad. It's pretty clearly a mess, but I want to point out exactly what the problems are in detail. So, this is an update animation function, so it's getting called every frame of the game. It's being called over and over in a loop. And the things that I want to point out are this part right here, this defensive coding is what it's called. And basically, what it's doing is every single frame it's checking, do I have a gun on this jet? Okay, and what I should have realized is that you always have a gun in this game. It's a shooting game, right? And so what I'm doing here is I'm taking a decision that I should be able to make as the programmer and designer. I should be able to realize that there's always a gun in this game. It's not playable without the gun. And that's a decision I can make at design time. And instead of doing that, I was lazy and I made the computer make that decision. So every single frame, the computer has to make this decision about whether there's a gun or not. That's just lazy. This part right here, this changing variable, and I'll talk about this more, but there's so many variables here that are kind of redundant. There's a lot of different things going on with this animation that it could really be done with a lot less. So let's talk about these state variables. So we have this change time thing, which is like, it takes, I think it was 1/4 of a second to do this whole little switching process. What I wanted to have happen was the gun would kind of rotate down into the, like inside the player model, and then I would swap it out for a different gun, and then rotate it back up. It was basically, that was the dream. And so I had this change time that was like the timer for this whole process to happen, right? So that's counting. Then we had this changing variable, like true or false. Is the gun currently changing, right? Then we had, what else? Oh, we had the current weapon group, and then you had this velocity angle x, which was like the velocity of it rotating, like all this stuff. But it feels like with all of that, that whole update function had all that stuff in it, but it feels like there's something missing. I'm not sure what it is. And I went looking, and it is the current weapon variable, which is in another file entirely, which is like an integer, like is this weapon 0, 1, 2, 3, etc. The real irony, it actually gets worse than that, is that I never even modeled different weapons. There was only the one little, because there was so much work, it was just the little black triangles. That was the only weapon in the game. And so all of that code about like swapping out weapon models, and I need to make sure that the model's there and then delete it and switch it with the new one and all, it was all just dead code. It wasn't doing anything, and it was just waiting for a bug to happen. Like there was a lot of complexity in there that could easily go wrong. So the moral of the story there is remove your dead code. It's a liability. Okay, how to improve, things I could have done better. Remove the duplicated state. So all those variables, all those things that I was keeping track of could have been done with two variables, right? You have a weapon switch timer, which is the timer to do the whole animation process, and then what weapon do we currently have activated? And based on those two variables, you can construct everything else, right? So if the weapon switch timer is greater than 0, well, that must mean that we're currently switching the weapon, right? So we don't need that true-false variable that keeps track of whether we're doing something right now or not. And then second, we need to make an upfront decision of when to initialize this stuff. So instead of leaving it up to the computer and checking constantly, oh, do I have a gun? Do I have a gun? We need to make an upfront decision and decide when do we create the gun, when do we, set it up. Don't leave that up to the computer. And obviously, with that if statement, what happened was one day I ran into a null pointer exception, and instead of actually figuring out why is the gun null, I just put like if statements everywhere to check if the gun is null, then don't do anything or whatever. I just sprinkled a bunch of if statements everywhere. In fact, every single function in the game that dealt with weapons started out with this if check to see if the gun was there or not. And there should always be a gun. Like, just let the game crash if there's no gun, because you can't play the game without it, right? So yeah, that's called defensive coding, where you don't really know what's going on. As the programmer, at any given point in time, I didn't know if the gun was even there or not. And so I always had to check. I was just always like terrified of whether certain things, I didn't even know if the ground I was standing on was underneath me, so I have to put an if statement to check if the ground is there, That's defensive coding. Okay, one more thing before we move on. Naming is incredibly important. I found this gem in the code somewhere. A Boolean that is called no enemies. And what this leads to is if statements like this, if not no enemies. And somebody suggested reading this as if ain't no enemies, but that's like still the opposite of what it really means, and yeah, it's bad. So name your Booleans positively. Don't name a Boolean disabled. Okay, name it positively, and also ideally make it so that it's initialized to false by default, because it makes a lot of sense for programmers to be able to initialize everything to 0 by default. Sometimes you can't always do that, and sometimes those are conflicting things, but 0 initialization is a really nice property to have. And in this case, we can get both by making this Boolean enemies equals false. And that's a win on both counts there. Okay, moving on. Oh, there was one more thing. This is exception handling. So this is how I loaded the gun model, and this is in just like a static block. These were scattered throughout the code, just in random places everywhere. It loads in the model from a text file. I told you it was a text file. And I just eat these exceptions and don't do anything if it fails. Now, you might be thinking, oh yeah, you know what, I do that sometimes too. I catch an exception and I don't do anything about it, or I should probably be more careful about my exception handling. I could probably like show an error message to the user, like ask them if they want to continue or not, or like something like that. That's not what I'm advocating here at all. I actually think there should be less error handling. I will say you can never have too much error checking. right? Like an assert or something. You should always be checking, having checks in your code for errors. But you can have too much error handling, which is if in your code you have the possibility scattered all throughout it to open up like a message box that says there was an error, and explain in detail what's going on to the user. That's your code is going to get bogged down by all this error handling. So what I would suggest in this case is just let the thing crash. Don't catch these exceptions. Just let it crash, because again, without the gun, the game is unplayable. And so again, you're kind of making this upfront decision that, look, I can't play the game without this, so I'm just going to let it crash. Or if it really is a recoverable error, like some kind of network error or something, then have something show something to the user or whatever. But like in most cases in games, you really need everything, and if something's not there, you just crash the game. Okay. Moving on to 2005, 2006. At this point, I learned C++. I got a book on C++ and started copying out of that instead of the Java one. And I decided I learned some DirectX, and I got some stuff on the screen, and I decided I've learned so much, I should share my knowledge with humanity and let, the common layman should be able to benefit from my vast knowledge that I have acquired in my 2 years of working on it. So I wanted to make an engine so that it could be reusable and other people could use the stuff that I had learned. I had like tutorials and everything, and it was awful. At this point, I learned that object-oriented programming is the big thing. It's very important, and you need to do object-oriented programming. And so I started writing everything in classes. So this was a class that I wrote called the mesh class, and it had all of this stuff in it. Just a bunch of stuff. So right off the bat, you might notice, looking at that I picked up the comments achievement. I learned to comment. The last game, there were no comments whatsoever. This one, I learned to comment. And when someone tells you that comments are good, you should write comments, like write more comments, you end up writing gems like this. That's the kind of, that whole class was nothing but these kind of comments. But there were some larger problems with this class. So let's take a look at, this is the data that was inside this mesh class. And if you look at it, it's very confusing because there's no real world equivalent to what this mesh does, right? So it holds like the actual data, it holds a file name for it, it has like materials, it has the center of the mesh, and it has these flags of whether it's translucent or all this stuff. It's got all kinds of things in there, and there's no real world equivalent to what is this thing. I just kind of took a bunch of stuff and lumped it into one class. So you might think, like, is it a data container? Does it contain like the actual vertices and mesh data? Yes, it does. Is it a resource loader? Like, does it load it from the disk? Yes, it does. It has a file name, right? And is it a renderer? Like, does it actually render things to the screen? Well, that too. It's that too, because it has these flags that determine how it gets rendered. And so it's all of these things at once, and it was just confusing. And so I didn't have a way to think about it as a real-world object. And the other thing was that it was very smart. Like, it has a lot of stuff inside it, and it knows about itself, and it knows about things in the world, and so it kind of had its tentacles everywhere. And so it was necessary to have these getters and setters that you saw in the last, all these get radius and is alpha, all this stuff. It was necessary to have these getters and setters because if I reached into this data, in here and poked around in it manually, something might break. So I can't let you do that. I have to do these getters and setters. So, how to improve? This is how I write this now. It's a simple structure. There's no functions, no methods, no anything. It just contains the actual data, right? It doesn't have a file name. It doesn't have any of that stuff. The mesh only is just a data container. Then I would have a separate system that loads it from the file and it puts it into the mesh object. And then there's a renderer that can read from the mesh object and use that to put stuff onto the screen. So all these like separate systems. The mesh itself is stupid. It doesn't know anything about anything. It doesn't have any functions or anything. And what that means is that I could copy this mesh I can move it around, I can do whatever I want without worrying about like, what is it connected to, or what things are going to break if I reach in there and poke around in it. Nothing, it's impossible to break this, right? If I add a vertex, like who cares? The mesh doesn't care, you know? So, it's a plain old data container. It doesn't have any smarts. One more thing about the comments. So this is my comment manifesto. What exactly, obviously those were some bad comments there. So what exactly was wrong with them and how can we improve them? I would recommend that we just delete them. Except for, well, the reason that I would delete them is that comments are not checked by the compiler. So if you make a change to your function and you rename a function, your code will no longer compile because the compiler checks it and where'd that function go, all this stuff. If you change your code but then don't update the comment, the compiler doesn't care. He'll let you keep that outdated comment there, and now your comments are incorrect and out of date, and it's just going to be confusing when someone comes and reads it. And so you should not write a comment unless you really need to, because again, it's another liability. It's just waiting to fall out of date and cause problems. So I say delete them, except for these few cases. One, comments that explain why something's happening rather than what. So instead of saying, this getCenter function gets the center, you should say, why would I want that, for example. Second type, comments that label a giant chunk of code. So if you have sometimes you just have a big function that's a big long process of stuff that just has to happen in order, boom, 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 boom. And sometimes it's useful to have comments that say, here's what happens in this whole big chunk, and then here's what happens in this whole big chunk. And it's just more like a label that you can use to navigate really through the code. And lastly, comments that explain the representation of data in memory. So hopefully, usually these are not necessary. But sometimes you have a concept that can't be mapped to memory perfectly or even very well at all. And so it's necessary in the data structure to explain, oh, this integer, if this integer is 1, it means this. If this integer is 2, it means that. 3 means this. And you can write that comment in the code. Those are the only comments I think there should be. Okay, 2007 to 2008, we don't talk about this because I was writing PHP. 2009, okay. 2009 to 2010, I started working on a Python-based multiplayer shooter called, and I'm not joking, Acquire, Attack, Explode, Pwn. It was called A3P. It was awful. I was in college at this point. I don't have any excuse for the amount of cringe that's going on here. But at this point in time, and you'll notice this pattern that with each project here, I picked up something, I read an article, and I kind of took it to the extreme. So last time I read, oh, object-oriented programming, it's great. And I just kind of went crazy with object-oriented. This time, I got this idea in my head that globals were bad. Global variables are not good. And this is common wisdom. You've probably heard something like this, that you should not use globals. So what exactly are wrong with global variables? Well, first off, what do I mean by global, and what would you use a global for? An example would be you are in an update function, the user has clicked on the screen, and you want to find the thing that they clicked on. Okay? So you might have a global list of all the objects in the scene, and you just go through the list and you find the closest one, and that's the one that they clicked on. So that's an example of maybe like a global variable, this giant list of objects. It's a global list of everything. Okay. Well, why is that bad? Well, the reason is that it can lead to spaghetti code. So if I have function A and function B, they're in totally different parts of my game. They deal with completely different things, but they happen to touch the same global variable. Now suddenly, if I change something in function A, it might break function B or affect it in some way, even though they're totally separate in my mind and they're not really related. If they both use the same global variable accidentally, suddenly they're connected to each other and things break. And so you end up with spaghetti code where everything is tied close together because they're all using these global variables. There's other reasons to avoid globals. One is that they don't work with threads. So if you have two threads and they both try to use the same global, things explode. So the moral of the story is don't use these things, they're evil. So this is what I came up with, the solution to this. I had a game object class, and instead of having a global list or whatever, I put it into a world object. And then I would pass this world object around to each thing that needed access to it. So it's not a global anymore because I have this instance of a world object and I can pass it in and operate just on that world. So this is great because the common wisdom is that you need to make self-contained functions, right? So I have a function, I pass stuff into it, it returns something or it operates on whatever I give to it, and nothing outside that little sphere doesn't touch anything. And that's good, we want that. So I thought, that's what I've done here, right? This object here is self-contained. It doesn't touch anything except for the entire world. But it's contained, So really all I did was take all of my global variables and I just crammed them into a world object and passed it around everywhere. But I thought this was great. I thought, you know what, this is great because I could have multiple worlds. I could have multiple worlds happening at the same time, if I wanted. I could have one server with like multiple games going on or something like that, if I wanted. The reality was, if you have any object in your game where all of your code has access to it, it's a de facto global, right? Just because you're passing it into every single function, that doesn't make it any better. The multiple worlds idea that I had, I never needed it. It was never tested, and my guess is that if I did try to do it, it would never work, and I would need massive amounts of refactoring. So really, I was just deluding myself that, oh yeah, I don't have any global variables, but really I did. Not technically. So once you start trying to do this, where you start teetotaling globals, I won't have any globals. You start to find some weird ways of deluding yourself, and there's some different patterns that people use to avoid globals by following the letter of the law rather than the spirit. So here's an example. You've probably seen this. This is called a singleton. So there are no global variables here. It's just this function, and then you call this function to get an instance of the thing. And what this does is it makes sure that there can only ever be one thing at a time. And so this will let you, now I can put whatever I want inside this thing and have access to it wherever, anywhere in the code. But it's not a global though, because it's returning from this function, so it's okay. It's not a global. This is like, this made me think of an analogy that my dad is a writer, and back when I was a kid, he told me his writing hit list. He has a list of things. Here's things that you should do to write well, things you should avoid. He told me to avoid empty to be verbs. So for example, instead of saying, I was thinking, you should write, I thought, right? Anything that's like, I am sad, you should say, I cried, or something like that. Have more interesting verbs rather than I am or I was, things like that. Anyway, I took this to mean that you should avoid all small words, like was, obviously, be, okay, good, the, it, to, all of these, like those are empty. I thought those are empty words, right? Because like they're so boring and plain, So I tried to write sentences and minimize the number of small words, or common words, basically. And my dad was like, "This is awful. What are you doing?" So this is what I think of when I look at a singleton. Is that someone tells you, "Oh, you should avoid globals." And there are good reasons to avoid globals. You don't want spaghetti code. And then someone says, "Oh, okay, great, okay, I'm gonna make sure I have no globals ever." And then you come up with like weird ways to get around it and kind of delude yourself into thinking that you're designing a system well. So this is technically not a global, but the reality is all the potential pitfalls still apply. Because this is accessible from anywhere in your code, you can have function A, function B that are totally disparate, and they can impact each other and break each other. You're just lying to yourself in this case. And in fact, singletons are actually worse than a global, okay? Because you don't actually know when this singleton will be initialized. If you think back to my example with the gun, and I was constantly checking, like, is the gun there? If not, I need to create the gun, right? I'm checking every frame if I need to create the gun. A singleton is the same thing. Instead of me, the programmer, deciding, okay, we're going to initialize this variable right now in the code. Instead of me making that decision, I'm leaving it up to the computer. Because if I never call this function, this singleton will never get initialized. Or if I first access this singleton, 10 minutes into the game, that's when it'll get initialized. Okay? So I'm leaving it up to the system or the computer to decide when does this thing first get initialized. And I'm not making that decision up front myself. And because of that, every time you access that singleton, it's actually an extra branch instruction. So this if statement here is actually a really expensive thing. And so every time I'm accessing this, the computer has to go through an extra branch instruction, which is more of a performance hit. So it's strictly worse than a global, is what I'm trying to say. It has all the same problems, plus a few more for fun. So I say just use globals. If it needs to be global, make it global. And this is something that it takes experience to know, and there's not really any shortcuts to know. Like you just have to write a lot of code and see this needs to be global, this doesn't, and still be able to, because globals are dangerous and it is possible to write spaghetti code with them, but avoiding them is not going to help you write better code. You just have to actually write better code. There's nothing wrong with grouping global variables together into a single structure like a singleton. I think that's totally fine. The real problem is code interdependence, two chunks of code that depend on each other. And if you can minimize that, global variables or not, then your code will be better and less interdependent, less spaghetti. So the problem is that most gameplay code is necessarily interdependent. Like I said, a lot of times you'll just clicking on the screen and figuring out what the user clicked, you need to access everything in the whole scene and loop through a whole list of everything to be able to check what did they click on. And that's just a really simple example. And so one way to kind of minimize interdependence in that case is to think of your game as a series of systems with well-defined boundaries. For example, you might have the AI system, the graphics system, the loading system, etc. And then a good way to enforce that these are separate from each other is to actually put them on separate threads and say, well, the AI system is its own thing, and I send messages back and forth to that AI thread, and that's the only way that I can communicate with it. And that way, the AI it's definitely not like reaching its tentacles into the rest of my game because it can't. It's on its own separate thing. Anyway, those are just some minor tips, but let's move on here. Boolean perimeters. I stumbled on this as I was reading, and I found this code where I have objects that can be deleted in the game. And like I said, this was a multiplayer game. And some of them, when you delete them, they just disappear. And other ones are like objects that can be killed, right? Like a player. And so I had I had basically 4 different types of death, right? You could be deleted, and that would happen on the local player or remote player, like the remote system, like so. On the server it's deleting locally, or it was some other person told us to delete it. And then I also had whether you were killed or not. Like, did you just get deleted and you just poof out of existence, or did you actually get killed and like there should be an explosion? This looks fine here, right? These 4 different types of deleting that I can do. But when I try to call this function, it looks like this. Delete, true, false. I have no idea what those mean. This is unreadable. And this is called the client code, right? This is where the client, I'm using this function, I'm calling this function. And so what you need to do is write this client code first. So when you're thinking of this whole delete function, don't start out by writing a delete function, right? Start by writing this code that calls it, okay? Because if I was thinking, okay, if I need to write a delete function, how would I do it? What would be the best way? If you start here, you're going to write it like this. But if you start here and you start writing this, you're going to be like, that's stupid. I would never. This is awful. I'm not going to write it this way. I'm going to write it this way, or something like this. This is much more readable to me, right? And then you'll go back and fill out and write each one of these functions, how they actually are implemented. So yeah, and the function was like 5 lines. It was just being lazy, really, is what it came down to. So yeah, write the client code first. Naming, once again, this is incredibly important. It might seem strange that I keep coming back to it, but it is one of the 2 remaining unsolved problems in computer science, alongside cache invalidation and off-by-1 errors. That's an old joke. What I would recommend here, the problem I have here, we have these 4 functions. 2 of these are obviously something about packets. 2 of these are obviously something about updates. And what I would recommend in this case is to rearrange the ordering of the name so that you have the general first and then move to the specific. So, I mean, I had a lot of packet functions. There was like a packet, there was like a spawn packet and a delete packet and all these different types of packets. And so it makes sense to organize all the packet functions and have the name start first. And the reason is when you are in your IDE with your nice autocomplete and you type, you know, this dot or self dot, and you see the list of functions, you want the related functions to pop up next to each other because it sorts them alphabetically. So it makes sense to name things starting with the general and then moving to the more specific because of autocomplete. Okay, last game, and then we will wrap up here. This game was the first one I actually finished. It only took me like 12 years to get to this point. And there were not a lot of small mistakes with this game, but some of the biggest ones were in this project. It was a 3D first-person game, parkour with voxels. So around this time, this was, what, 2010? Around this time, we were getting really excited about data binding. So like I said, every single project, I had some new technology that I was really excited about, or whatever, and I just went insane with it. So this time, it was data binding. Some examples from the time was MVVM, if anyone's used that with Windows Presentation Foundation. Today, we have React and Angular is kind of where this ended up going. All of these different functions, or all these different libraries and things, have the same basic promise. This is the dream. If you go to like Angular's website or whatever, they'll probably show you this. You have a text box, an HTML text box. You have a label here, and you type in here, and I can't type it all. You type in here, and the text box updates automatically. Whatever you type in here gets reflected, and it's in real time. It's so responsive. And usually this is done with a single line of code, where you basically, all you have to say is label equals text box, or bind these 2 together, and it just automatically happens. Everything updates automatically. You've probably seen demos like this. And you get really excited. And this is how it would look in a game, for example. We have a player class, they have a name, then you have like your UI code that is rendering stuff, and then I want to bind these 2 things together. This is how it would look in my engine that I ended up doing. I would create this binding, and it would link the label to the player's name. And whenever the player's name changes, if that ever happened, it would automatically update. And this is so exciting because now I could keep my UI code and my game code totally separate. They're totally separate. They don't know anything about each other, and yet it's updating automatically and all this stuff. It's very exciting. Well, I ran into some red flags, so here's how I implemented this in the end. I created a property class, so every single field in the game was a property object. So instead of just having a Boolean in my thing, I would have a property of Boolean. Okay, so it would store the actual value here, and then it would have this list of all the bindings that depended on that variable. So if I had a Boolean flag, I could have these bindings, and anytime that thing changed, it would update all the bindings and then propagate all these changes throughout wherever it needed to go. And if you notice here, there are some issues right off the bat. This is like every single, down to the last field in the whole game, had a list attached to it. Okay, so even if it was just a Boolean, like 8 bits, it was probably at least 64 bits in size, because it has this list of property bindings that it's attached to. And in the worst case scenario, it actually allocates on the heap memory, which is a huge, huge problem for performance. The other issue is, you might start to see a hint of it here, but there is this weird loop where I actually start at the end of the bindings list and then loop down and go backwards through the list, notifying the bindings. The reason I had to do this was sometimes a property would change, and that would cause the code to create new UI elements. For example, I would have bindings and all this stuff set up for the list of save games. I'd have a list of save games, and you could select which save to restore. Well, if I added a save game, that creates a new element, a new UI element, and that changes the list of bindings and stuff. So in the middle of updating this stuff, the list might change. And that caused all kinds of issues, and I had to do weird things to make sure that everything kept working. And of course, I took things way too far. So the whole game was written this way. Not just the UI code, but everything. The jumping, like this is the movement code, if you see. I have like jumping in here and wall running. All the parkour moves were done this way. It was a disaster. I would have like everything's totally separate, but then bound together with bindings for no reason really. But there were other issues with this. I had infinite loops, so this thing depends on this thing, which then depends on it again, and you have an infinite loop of bindings, and so that was bad. I found out that oftentimes initialization order is important in games. It matters what things get initialized first, and when you're creating bindings, it's difficult to control that, and a lot of times you would have things getting initialized twice and all kinds of stuff. And I never really figured this out. I just kind of messed with stuff until it worked. Another issue I had with data binding was it's difficult to animate from one state to another. So it's very easy to, if you have a Boolean and then you want to turn off and on something else, it's very easy to instantly propagate that change. But it's difficult to do an animation from one thing to another over a period of time. Data binding isn't really made for that. And so this is not just me that has had this issue. There's actually a Netflix talk that I will link at the end here, where they talk about, they rewrote the Netflix client in React. The current Netflix client is written in React. And the whole talk was talking, well, it started out him praising React and how amazing it was. And then the rest of the talk was spent explaining all the ways that they had to work around it and like pledge it to make it work. So what the solution that Netflix actually arrived at because they had the same problem with animations. It's difficult to do animations with data binding stuff. So what they came on, the solution that they arrived at was, we disable React, we play the animation, and then we turn React on again. And that's what they did, and I mean, it makes sense to me that is what they arrived at. So because I too had that same realization, and I realized the benefit of having an on-off switch. So I added it. I had this binding class, and I decided to put this enabled flag in there, and it wouldn't propagate any of the changes unless the enabled flag was turned on. But now, every property has, we've created more state here. Really the goal of data binding is to minimize the amount of state here, right? Because we have our state of our game, and we have the state of our UI. And really, we don't want the UI to have any of that, any state. We want to have just the state of our game, and we can construct the whole UI based off of that. So that we want them to be kept in sync all the time without us having to worry about it, is what the whole point of data binding is. But now we've created more state. We've actually added a new property here, this Boolean that we've added here. And so now we have to manage that and turn that flag on and off manually ourselves. Well, how can we reduce this state? We got to get rid of this state now. I know, we can use data binding. So we can bind whether this binding is enabled to some other property and determine, yeah, I actually tried this for a while, and then I finally realized how crazy it was that it's just not going to work. So the goal is to reduce the state like functional programming, but actually creates more state. Data binding was not the answer for me. For me, what I would say is you need to make your UI actually functional and stateless. So it takes the state of your game and it actually just renders it out to the screen without having any kind of state in between. This is usually called like immediate UI. A great example of this is Dear I am GUI. I don't really know how to pronounce it. It's weird. But there's a library called IMGUI, and it's an immediate mode library where there's no state. You just call functions and it shows stuff on the screen. And what I would say is that it should be a pain for you to create state. Like data binding, I could create state without even thinking about it by tying these things together. Each data binding is itself state. You know, it's the list of bindings and all that stuff. So I think that it should be a pain for you to create state. You have to manually go in and create a variable and manage it and all that. And if it's painful for you, then you won't do it as much. And so you'll have less state. And then lastly, I would say try to separate the behavior and the state. So you have a variable, well, like this binding here is both behavior and state at the same time. A binding is a relationship between two things, right? It's saying this is equal to this. But at the same time, it also is state because it's an object in memory. And so it's both things at once and it's tied closely together. And what I would recommend is to have your code separate them as much as possible. So you have a function that doesn't store anything, it just is behavior. And then you have a structure that is totally separate and it doesn't do anything, it just contains data. Try to keep those separate as much as possible, I think, in just my opinion. And there was much more on this game that were just massive, massive mistakes. I tried another creative approach to globals. I had every single object in the game had a pointer to the world object, which was just a waste of memory, really. I got addicted to closures for a while. Those were bad. That's another bad example because it's very easy to create state there because you can just capture a local variable and suddenly it's on the heap. I tried to create an entity component system and it was none of those three things. I tried to do multi-threading by basically throwing half of my code on another thread and then just sprinkling locks everywhere, which was bad. But we don't have any time to talk about that. There were many mistakes made. Takeaways from this talk and all the terrible code in it. 1, make decisions up front instead of lazily leaving them to the computer. So decide when you're going to initialize that thing, and then make the rest of your code just assume that it's going to be there, and just let it crash if it's not there, because that's your fault as the programmer. You did something wrong. Separate the behavior and state in your code, like I said. Functions and state, I think, can be separate as much as possible. Object-oriented programming likes to group them together. Sometimes that works, but I like to keep them separate. Write pure functions if you can. So input, output, nothing in between. Don't reach out to other functions or other state and try to modify it. Write the client code first, like we saw with the delete function there. Write the client code first and then go implement it. And write boring code. One thing that I've noticed with all of these examples was I got excited about some new technology, data binding, whoa, or some really fancy, nice way of doing things, and it ended up being a disaster. So I advocate writing boring code. Step 1, 2, 3, do this, do that, and just really simple. And that's all I have. I wrote an article on all this. If I'm not a very good speaker, so the article's honestly much better. And it's on my website, so you can check it out. Thank you.